Goedemiddag naar al onze kijkers. Vandaag hebben we een speciale gast. We hebben Carlo Fragni, Senior Engineer van Cartesi. Hello Carlo, how are you doing?
Doing fine, great. How about you?
I'm very good, thank you. Well, I like to start usually with a bit of a background information. So, I've seen that you've worked in, from low-level systems to large-scale business software. What kind of mindset or curiosity is it that led you into blockchain?
It's a bit of a funny story, right? So most engineers that I know, whenever there's a new tech, they want to give it a try, right? And see what it's about. But there are a few technologies in which you just cannot commit like half an hour and learn it, right? So AI, for instance, and blockchain is one of those. So when the opportunity came, I just took it because I was super technically interested in it. And I knew it was that kind of tech that you don't learn if you don't really live it, right?
Yeah, so it's one of those things that, you're really sucked into it. And it's definitely not something where you can spend half an hour and feel like you know everything. So it is either you're in or you're not. So I'm just, always curious to see what leads, developers to go into blockchain or AI or, other forms. I wanted to, for readers who maybe haven't followed up on Cartesi or don't know exactly what the project is, could you maybe describe what it is and what it does?
Yeah, sure. So Cartesi was born out of the idea that we have a lot of really cool stuff and properties on blockchain, but we do struggle on computational amount that we can perform on chain, and also on how you can express yourself, because Solidity is basically reinventing the wheel, but it's much more limited than the traditional languages you're used to when you're developing on Web 2. So the idea of Cartesi is let's bring all this tooling from Web 2 and also the computational power that we demand for more complex applications, but keep all the security and decentralization, all the nice properties that we have on blockchain. So that's the idea behind Cartesi.
Yeah, so essentially Cartesi lets developers create app-specific rollups that still anchor to Ethereum security, so to speak, blockchain security, and each application gets its own dedicated execution layer rather than sharing all the compute like you would on another layer too, like for example Arbitrum or Optimism.
Yeah, and since our machine is based on RISC-V, we can run Linux. That allows us to have all the goodies that Linux brings, like the services, the languages, the libraries, everything. And it's super safe because two of our founders are actually like super genius from mathematics, right? And they developed this super interesting algorithm that allows you to secure any computation with a single honest party. So even though you do this really large computation on what we used to call like a local quorum, because you have few parties that are interested in it, a single party on that small consensus is enough to ensure the security. Because if there's something wrong, they just resort to the dispute algorithm that actually executes on top of Ethereum in smart contracts. And a single party just proves that they're correct.
And this is why why you would say this approach is better, or what this is the problem that Cartesi is solving in a way.
I mean, it's a very powerful idea, right? Because like you think every day you go to the bakery and buy bread and all this stuff, but you don't go to court about it, right? Nothing is like final. Then if you have an issue, then you can always resort to court and establish what's the right thing, right? But if you think about it on blockchain, on base layer, everything is final. So it's a lot of overhead, right? You have like these hundreds of thousands of nodes, all of them checking that what you did is right, despite no one claiming that there's anything wrong with it.
I see. And you mentioned Linux, basically Linux. It's essentially Linux on the blockchain, which sounds, I don't know, sounds pretty crazy for someone who might not be into, I don't know, developing or just a regular blockchain user and only focuses on things within coins, tokens, and doesn't really think about the technology behind it as much and how to build the dApps. Can you give maybe a practical example of something that would be difficult or painful to build on Solidity, but simple and like simpler inside Cartesi's Linux, VM?
Yeah, sure. I have a pretty good example. So I'm part of a team that builds an application called Rives. which is on top of Base currently, and super cool. So what's the idea? We have this virtual arcade, it's a virtual game console, and you can run like super complex games on it, and you have everything verifiable. So there's a lot of stuff in the gaming community that lacks transparency and sometimes is attacked. So you speed run a game. The way you prove it is generally just film it and you put the video on YouTube. But how can you make sure that's not AI or that's some other user that sent you their recording and then you claim that's your score, this kind of stuff, right? So these drives, what happens is we have the Cartesi machine, which is the same that we run on the Appchain, running on the browser. So we compiled it to WebAssembly. And then we have what we call a cartridge, which is basically the code and all the stuff from the game you're running, right? You load it on your browser, and you need to run it on a very powerful fashion because it's inside the Cartesi machine. While you're playing, the Cartesi machine is recording all the key presses that you do. Like I jumped, went forward, I fired, all the stuff, and the moment in the game in which that happened. Once you're done playing, you submit it on chain. And once it's on chain, we have the Appchain from Rives picking up that gameplay, all the moves that you did, putting inside the Cartesi machine, picking up the same cartridge, and re-executed the entire thing. And then it's not like I claim that I did this score or I did this achievement. No, it's everything. It's verified. All the how many lives you had, how much damage you did, all the stuff that you're trying to claim. Everything is verified, and it's fully transparent and disputable. So it's super powerful.
That's very, very interesting. I did not know this. It's a very interesting way, I guess, to make everything verifiable, make sure people don't claim scores that they didn't have in this exact example. And it leads me to, you mentioned RISC-V architecture. Mm-hmm. For someone who doesn't know much, about developing, including myself, why choose RISC-V over other forms, and what does it enable you to do compared to other setups?
Sure. So nowadays, RISC-V is like super popular. Vitalik is discussing about using it as the core of the Ethereum nodes and all the stuff. But in 2018, back when we started using it, it was a bit of a novelty. So the logic behind using RISC-V is that we needed a deterministic machine in order to make the idea of Cartesi work, right? Because if the machine is not deterministic, then you cannot have different parties doing the same computation and achieve the same result. So they won't agree on it, right? So back then, what one of the founders, Diego, thought was, okay, so let's adopt RISC-V mainly for two reasons. The first reason is that it's an open platform, so it's super well documented, okay? And it has a very simple instruction set. So it's going to be much easier to make a great emulator that actually works within the specs and that performs well. And the second reason is that RISC-V was compatible with Linux. So it's not like we're creating a super powerful machine that can compute a lot of stuff, but we'll have the same problem that the EVM had of recreating everything. No, by having a platform that's compatible with Linux, we can just import all the goodies and have a super complex and rich development environment for everyone available.
I see. Well, thank you for clarifying that up.
Yeah, sure.
And in terms of building experience, I know we touched on, if you're a Web2 engineer, in order to move on to blockchain, like you had to thoroughly actually be interested in the topic. You're not just going to move from one day to the other. Say I'm an engineer who knows Python or Rust. Is it how fast could I spin up, a demo on Cartesi? What's the workflow like?
It's pretty fast. So you can head to our documentation on the main site and check it. But basically what you do is you install something we call the Cartesi CLI. And by using a couple of commands, you create a new project, which might start from a template. Python, Rust, multiple languages do have an initial template. And this initial template will do like the basic stuff that you can do on a Cartesi program, right? Which is waiting for an input. When it comes, you just print it. And printing it means we emit an event on it, right? It's a special event from a Cartesi node, which we call a notice. And then wait for the next stuff to process. So it's super simple. And you already get this template with this basic code in there. And there's it's Python, C++, JavaScript, Rust. There are many different languages in there. And once you do this very basic stuff, then you can get on like heavier stuff and more complex. Everything is created from a basic Cartesi machine, which has a Docker file that you use it to build it. Most developers and people that have some DevOps knowledge, they do know Docker. So you can go there and put all the stuff that you need to create the rich environment that you want, like install services, libraries, all the stuff that you're going to need.
Okay, so the building experience is quite like versatile in itself, and I guess if you're a developer, you quite not straightforward, but to do the minimal basic, it is quite feasible. And
the
quite
minimum basic, it's super fast, yeah.
Super fast,
and then your imagination is limited.
Of course. And in terms of like real projects and use cases, where are you seeing the most interesting early projects? The AI, gaming, DeFi, and is there a specific community project that really shows off or stands out?
Well, I think there are multiple, right? It's different to pick up one. As I mentioned already, gaming is something that I think makes a lot of sense. On Rives, if you check it, you can run like the open source version of Doom, which is Freedom, which is something that you cannot do like on a regular laptop, like without any other tech, as far as I know. Like you can do it on ZK or stuff like this, but then like RISC-V, for instance, which did a proof, they didn't run on OS, and they did it directly on hardware, which is not very easy to do because you have to modify the entire libraries, all the stuff to act directly on hardware without the OS abstractions, right? And it needed like a cluster of super computers on Amazon, basically, to validate it and generate a zero-knowledge proof, right? So that's an advantage of optimistic rollups. Then we have a lot of very interesting applications. So carbon credits, for instance, is a market in which there's not a lot of transparency, right? And it's becoming super important as the environment becomes more critical every day, right? And there are a couple of really cool applications that do something like, okay, I'll give you carbon credits for restoring some forest. How do I claim it that I did a restoration and make it verifiable? Well, you can pick up, for instance, satellite imagery, and then you use OpenCV and other libraries like YOLO and other machine learning libraries in Python. And you can just identify on this image what's the forest area, and then you compare it to another one later. You check the difference. Oh, it did grow like 20%, and this gives you like 4 carbon credits. And then you have like super transparent and audible carbon credits, which I think it's something super important for not only for the current economy, but for the future economy as well, right? Then we have all these AI applications that are super cool. So you can do like sentiment analysis, a lot of stuff inside the Cartesi machine because, well, you can just use Python, all these models, all this crazy stuff. There's this very nice experiment which was performed by one of the guys from our team, in which he picked up a small language model, like large language model, like 1 billion parameters or so, and he made it deterministic, and then you could have like this native running directly on hardware LLM, which would answer you stuff like super fast. But if someone wants to check it or disagrees with it, you can just run the exact stuff inside the Cartesi machine and there will be no difference. So you have like native performance when you're using it like on normal mode. But if you want to check something, then you can execute it slower inside the Cartesi emulator and it will match exactly, which I think is super nice. Yeah, there's DAO stuff, which is also super cool. Risk calculation, because a lot of stuff in DeFi would benefit from like better checks, because you do have very few computation available on chain, so you cannot do something like black shows and stuff like this. Yeah, you can just plug in Cartesi and do this more sophisticated analysis using the same stable libraries that banks have been using for decades, right? Which is super good because even basic stuff like logarithm that we take for granted, there are a lot of perks implementing it. It's super easy for you to make a bug. And if you do have that bug and you put it on the DeFi protocol, that becomes the next like $100 million loss, right? When someone exploits. So that's super important.
That actually, that that bug part leads me perfectly onto the bug bounty honeypot to test Cartesi's fraud proof system. I was wondering, what have you learned from that experiment? Did it change how security is approached by Cartesi?
Yeah, it does. So the general approach in crypto is like you do internal testing, then you have like release candidate, and you really put effort trying to break it. And once you're confident, you just pay some external team to audit, right? But it's very limiting because it's most likely for someone to find a bug if it's from the team, right? Because they're into all the design decisions, they know the limitations, the corner cases, done their homework on the dependencies, how they fail, all this kind of stuff, right? An external team is like super hard. They sometimes use like formal verification tooling and this kind of stuff. But still, when you pick up something, it's like something minor that doesn't really affect any outcome. And it's hard, right? Because you're just crash landing on a lot of code that's generally complex. It's very unlikely that you find something, right? So the idea behind the honeypot is, okay, so security is not something like no one's going to catch a bug on this window. It's not going to happen. It's something that should be continuous. And there's a lot of white hat hackers in there that you'd like to give some money if they benefit from something like the honeypot is great. And there's also some hackers that are like, they'll do whatever benefits them the most, right? So if you offer them money, they'll do the right thing. If you don't, then they will just exploit it, right? So the honeypot also should capture this kind of hacker, like kind of a gray hat hacker, right? And yeah, I think that's the idea, is to have a continuous program. As the time passes, we grow more confident that there's no exploit in there. So the idea is that we keep increasing the amount that's locked in there, right? And also the idea is that it's kind of like it should be the first place to blow up if there is a security issue, right? So there's a security guarantee that it's kind of like, okay, if someone is going to do like a 0 day or something, they'll go where there's more money to be gained, and it should be the honeypot. So whatever application you deploy on mainnet using that version of the Cartesi SDK should be safe, because if there's something wrong, they should go before to the honeypot because there's more money in there. So it's a different approach, and I think it's super interesting.
And this is bug bounty honeypot is mainly just to incentivize, I guess, well, I don't know, gray hat hackers or white hat hackers to test around with Cartesi's like how Cartesi works, or because you mentioned do they do security audits externally, Cartesi, as well, or is it purely internally, and then the external security audits come from individual hackers or developers who want to test it rather than a company doing it?
Yeah, currently we have a lot of internal auditing, like the traditional process, and then we rely on the honeypot. And whenever there's a security team that comes and wants to do an audit, we just say, hey, get into the honeypot, feel free. And if you crack it, you just get the money. There's like no bureaucracy or anything like that.
So rather than doing like a partnership with how other crypto projects, like you said, would go to an external party and pay them to figure it out, here it's more like if you crack it or if you figure it out, you get paid. And
if you crack it, it's yours. Yes,
it's your own time, and if you're willing to do it and spend time on it, be my guest. Okay, yeah. Interesting. That's interesting. And in terms of the I guess roadmap or outlook for Cartesi, I've seen there's been in recent updates mentioned like Rollups Node v2, multi-dApp node support, bond systems validators. What's the bigger picture here, and how do these pieces make the ecosystem more ready for like real world apps?
Yeah, so the Node v2 adds a lot of performance, let's say, makes the node very robust, much faster, puts way less overhead than Node v1, which is great because that translates into more stuff that you can do in your dApps and also lower costs, right? It's very much optimized. Then we're also improving all the tooling, the interfaces, all the stuff, which is also great because it makes it easier for developers to build stuff, lower overhead, lower cost, all this stuff. The multi-dApp is also based on lower overhead and cost operations because now the node will be able to babysit multiple dApps. So you don't need like a separate environment for each dApp that you're validating. You can just validate multiple on a single machine. And that especially lowers the cost if you validate multiple dApps that don't really have a lot of traffic. Because then instead of having multiple servers that are just standing there, you have a single server that's actually using its capacity, right? So that's great. Then we have what I think it's the most exciting stuff, which is Dave coming. So the first version of our dispute resolution was great for disputes, but it was one party to one party. And whenever there was a new dispute, it would delay finality. And even though it's way less important than on a single rollup like Arbitrum or Optimism, because it's an app chain, so you're just delaying a single application, not the entire ecosystem. It's still good to have like a faster finality, right? So Dave tackles it. It's we have a paper that's published. We're doing all this research in the open. There are entries in the IF research forum, all this stuff. And David has a very clever way of making sure that all possible disputes happen really fast. And it has a very nice property that it doesn't matter if you're just a guy, a regular guy with a laptop and not a ton of money. You'll still be able to defend your point of view and make sure that your computation that's right is going to be the final one, despite having people with state resources. I would say like the state of Japan tries to attack your rollup. It doesn't matter, because the way Dave is done is that an attacker will grow exponentially the resources they need to try to attack you. And the defender adds just a bit of resources whenever they have to defend against these massive SIBO attacks or stuff like this, right? So it's super cool, and it's a very, very powerful protocol.
It's a very, very democratic approach.
Yeah,
which I do like.
Yeah, should be super decentralized. Anyone, despite of money and computational power, should be able to defend their position, right? So
yeah,
that's what we're tackling.
It's a good incentive as well for developers who might feel like, oh, I'm doing it solo versus against the whole conglomerate of people, which kind of disincentivizes people sometimes. So it's pretty very cool application to it. And this leads me to my last question, which is, if you had to summarize Cartesi's promise to developers in a few lines, what would it be?
I think it's a tough one, but basically when you see a lot of applications on chain, they're really not on chain because you lack the tooling and you lack the processing power. So you do like a Web 2.5, and then you have to put a lot of trust on a centralized party doing that complex part, right? So that happens on gaming, that happens very often on DeFi, and a lot of things that you see around. With Cartesi, you can actually make this decentralized, unverifiable, and trustless. So I think that's the most powerful stuff from Cartesi. It's actually picking up super complex stuff that you need without using the tech like a central server or an Oracle or stuff like that, and you can actually make it trustless and decentralized.
Oh, lovely. Yeah, because that is, I guess, a lot of people's concerns with some blockchains where it's like it is decentralized to an extent until like the nodes points are run on something that's very centralized, or cloud power that you need, which is also very centralized for certain things. So awesome. Well, thank you very much for your time. That was the end of the interview. Very, very interesting. And yeah, hope to see you soon and speak to you soon.
Thank you as well, Raul, and hope you have a nice day and a nice week.
Thank you. You too. Ciao.
Thanks for having me. Bye-bye.
No worries. Bye-bye.